So this one is asking us to find the domains of two composite functions, first f of g of x and then next g of f of x. So let's just start off by focusing on this one. To find the domain restrictions of this, we first need to find the domain of the inside function, which is g of x. You'll notice g of x is linear, and therefore it has no restrictions. The domain is all real numbers. So we can go ahead and just move on to finding the composite function f of g of x. You're just plugging in the entire function g into f. So here where you see x, we're instead going to write 1 minus 2x. So this is f of g of x, which I can simplify a little bit. I have 1 minus 2, which is negative 1. Okay, now I can go ahead and find the domain of this. It is a square root function. I know the radicand must be greater than or equal to 0, so we can set up an inequality. And the solutions to this inequality will be the domain. So I'm going to go ahead and add 1 to both sides. And divide by negative 2. Remember that when you divide by a negative, you do switch the inequality to face the other direction. Okay, so I have x is less than or equal to negative 1/2. So my domain will be from negative infinity to negative 1/2, bracket, to include the negative 1/2. So now let's try the other one, g of f of x. So for this one, the inside function is f of x. F of x is a square root function. It has a restricted domain. In other words, x minus 2 must be greater than or equal to 0. Add 2 to both sides. X is greater than or equal to 2. So now that we've found the domain of the inside function, we need to go ahead and find the composite function. So that is g of f of x. So we replace the x here with the entire function f. So that will be 1 minus 2 times the square root of x minus 2. So this is the composite function. Notice that it still contains the same radical expression as the original function f. So the domain will be the same as the domain of f. So as x is greater than or equal to 2, as an integral notation will be bracket 2 comma infinity.